So D'Arsonval movement can be said something like this. So a moving coil is mounted on a pivot between the poles of two magnetic poles, so let's say N and S, and there's a moving coil. So this one can move, and if a current flows through this coil, and because of the presence of magnetic field there will be a movement. So if there is a pointer here, the pointer will experience a torque. As a result, it can move in this direction. So if there is a scale here, that can be a measure of the current. It can be calibrated so that it can give the measurement of the current, or at least the presence of current. It has to be modified a little bit to get a to be able to measure current or voltage. But as we can see, on principle, this one can show the presence of a current, and this one will be full deflection. So if we want to, this is just D'Arsonval movement. Now this one can be modified to get a voltmeter. What happens in a voltmeter, instead of showing the whole thing, we'll just draw something like this. So maybe this is the meter, and it has a resistance, a resistance which is of a very high value. Usually it's made for voltmeter. So let's say this resistance is Rm, and in addition there is another resistance which gives the voltmeter's range. So let's call that Rn, and the voltmeter is connected in parallel with the element that's the voltage it wants to measure. So let's say this one here, the element is connected here. So the circuit is there, the element is connected here. So the voltage is E, and Rn can be varied. It can be different according to the range of the voltage that we want to measure. So Rm is actually higher usually, because we don't want the meter to draw too much current, because so that the circuit is not affected. Basically it should work as an infinite resistance theoretically. So let's say a situation, before that, let's say when the meter is drawing full scale current, or when the pointer is pointing full scale, that is the maximum current it's drawing, let's call that current IFS, and that is the maximum voltage it can measure. Let's call that VFS, which it can measure. Let's say VFS, the full scale. So in full scale situation it will be IFS Rm plus Rn. So basically we are trying to find what has to be the resistance Rn to decide the range of the meter. So the range we should be able to vary the range. It can be if we want to measure a voltage from 0 to 1, or from 0 to 5, or from 0 to, let's say, 10, or 0 to 100, like that. So according to that, the Rn will vary. So we get that Rn becomes VFS IFS minus Rm. That will be the value of Rn. So let's imagine a hypothetical situation, like we have the meter draws full scale IFS 100 microamps, and the resistance of the meter is, let's say, 1k, 1000 amps, or 1k, whatever. So we want to find what should be the value of Rn in order to get a range of 0 to 1. So the maximum voltage we want to measure is 1. If we want to do that, what will be Rn? So Rn will be now 1 over 100 into 10 to the power minus 6 microamps, minus this one is 1000. We are converting it into ohms, so that becomes 10,000 here, 10 to the power 4 basically, minus 1000. So we get 9000 ohms or 9K. So the value of R will be 9K if we want to measure the voltage, if we want to make the voltage range to be just 1 volt. Now let's say we want to make the range to be 10 volts, 0 to 10. If we do that, Rn, now the full scale voltage will be 10 volts divided by 10 to the power minus 4, because 100 microamps minus 1000 here, so it's 10 to the power 5 minus 10 to the power 3, so it becomes 99 kilo ohms at this stage. So this is how the range will change, range of resistance, the resistance will change. So what can be done is, this is the meter resistance, and let's say this is the meter here, I don't know, like that, and the resistance can be, there can be various resistances like that, and there can be a switch. So the switch will be here or at position 1 or position 2 or position 3 according to the range of the meter. So if it is, let's say this is for 0 to 1, for that it is 9 kilo ohms, for 0 to 10 it will be 99 kilo ohms, and so on. So this is how the meter can be designed, the voltmeter we are talking about. So this is very simply the general principle of a voltmeter, analog voltmeter.